All right, get ready for this one because we're tackling a real head-scratcher today, the information paradox.
Oh yeah, this is a good one.
You wanted to really dig into this whole concept of information, how it connects with entropy, and what it all means in the grand scheme of things.
And you found the perfect video to get us started, right?
Exactly. This one from Homo Deus called La paradoja de la información que gobierna el mundo, which, translates to
The information paradox that governs the world. Catchy, right?
definitely grabs your attention. But seriously, where do we even begin with something like this?
Well, like the video does, I think a good starting point is that apparent contradiction we see between the second law of thermodynamics,
Hmm.
entropy always increasing, and the fact that we see all this order and complexity popping up everywhere in the universe.
It's a real head scratcher. How does that even work?
It's a question that's been a puzzle for scientists for a long time. And the video does a great job at showing that struggle through the story of Ludwig Boltzmann.
Yeah, I felt for the guy. He really seemed to be wrestling with this paradox.
He was brilliant, though, a real pioneer in thermodynamics. He was the one who figured out that if you're looking at it statistically, disorder is just way more likely than order.
Okay, that makes sense intuitively. Like a deck of cards is more likely to be randomly shuffled than in perfect order.
Exactly. So the question then becomes, if the universe leans towards disorder, how did we get from the Big Bang, this state of pure energy, to galaxies, stars, planets, and, well, us?
Right, that's the paradox.
Exactly. And Boltzmann saw this increasing complexity in the universe, particularly in living things. And it didn't line up with this idea of entropy always increasing. It was like a piece of the puzzle was missing.
And that piece, I'm guessing, is information.
Bingo. And that's where Claude Shannon makes his grand entrance. He developed information theory, which gives us a way to actually measure information mathematically.
Okay, so we can put a number on it, but how does that solve the paradox?
Well, here's where it gets really interesting. Shannon's formula for information is strikingly similar to Boltzmann's equation for entropy, just with a flipped sign.
So are you saying that information is like the opposite of entropy? That it's somehow fighting against this universal movement towards disorder?
It's not quite that simple,
Yeah.
but you're on the right track. It's more like entropy is all about randomness, while information is about order and structure. The more information something has, the more organized it is, the further from that random state of maximum entropy.
Okay, I think I'm starting to grasp this, but I think a real-world example might help me wrap my head around it a bit better.
All right, well, the video uses a very memorable one. A Bugatti Veyron and a tweet.
A tweet? Okay, I'm intrigued, but I need more context.
Okay, imagine you take that Bugatti and completely demolish it. Smash it into a million pieces.
Ouch. That's painful just to think about, even hypothetically.
But bear with me, you haven't actually destroyed the atoms that made up the car.
Right, they're still there, just scattered everywhere.
Exactly, they're all still there, just completely rearranged. What's gone is the information, that specific arrangement of those atoms that made that pile of scrap metal a high-performance machine.
So it's like the difference between a pile of lumber and, say, a beautifully crafted house. Same basic materials, but the house represents so much more information, so much more organized complexity.
Exactly.
You got
And that's precisely what the video from Homo Deus is getting at. Life, intelligence, technology, they all represent this increase in information. It's ways of arranging matter into these incredibly specific, complex structures. Like the universe is finding ways to pack more and more information into itself, even as entropy is trying to pull things apart.
Whoa, this is really making me think. But if information is so crucial, how does it actually last? I mean, everything eventually breaks down, right? Even Bugattis get smashed, as we just explored.
That's a great question, and it brings us to another important point the video makes, the role of solids.
Solids, like
Yeah.
rocks and stuff.
Yeah, think about it. Liquids and gases are constantly moving, their molecules all jumbled up. That's why a whisper fades away. But a message carved in stone can last for centuries.
So solids are almost like the universe's hard drives, storing information in their very structure.
Exactly. And it's not a coincidence that life, the most complex information processing system we know of, relies heavily on solids.
True. DNA, proteins, even the bones that hold us together, they all provide a stable structure for information to last.
Right. They provide that stable framework for information to persist. But here's something else to consider. The video also talks about how this ability to process information, to compute, isn't limited to living things.
Wait, really? So I'm not the only one in my house who's doing computations. My dog's snoring over
Huh.
there. He's processing information too.
Well, he's definitely processing something. But even simple chemical reactions, they involve a kind of basic computation.
Hold on. Are you saying my morning coffee is crunching numbers while I try to wake up?
Huh, in a way, yes. It all comes down to how atoms and molecules interact, exchanging energy and information. The video even uses the example of a tree. It takes in information from its surroundings, sunlight, the temperature, nutrients, and uses it to grow and adapt. So in a very real sense, it's a living, breathing computer.
I'll never look at a tree the same way again. But you're right. It is constantly responding to what's around it, making decisions about how to grow, where to send its roots. It's like it's constantly processing information just to survive.
And then there's us, humans. We've taken this whole information processing thing to a whole other level.
Right.
We don't just process information to survive, we use it to create, to innovate, to build entire worlds in our minds. And then we bring those worlds into reality.
You're talking about the iPhone, the internet, the entire technological world we've created.
Exactly. It's like we've become masters at translating information into tangible things.
Taking the raw data of the universe information and sculpting it into our own creations.
The video calls these creations crystals of imagination, which I absolutely love.
It's a beautiful way to put it, because if you think about it, a smartphone, a skyscraper, even a piece of music, they all started as just an idea, a spark of information in someone's head. Then we use our collective knowledge and tools to turn that abstract information into something real, something that interacts with the physical world.
It's incredible, right?
It's mind-blowing. But this is just the beginning, isn't it? What happens when we push this ability to its absolute limits? I mean, the video mentions some pretty wild ideas. Dyson spheres, harnessing energy from black holes.
Right, right.
Yeah.
It's like science fiction is starting to look more and more like science fact.
So where do we go from here?
Well, to answer that, I think we need to dive into those mind-bending possibilities in a bit more detail.
Okay, so crystals of imagination. I love that idea. But where do we go from there? What happens when we want to build even bigger than smartphones and skyscrapers? The video brought up these things called Dyson spheres, these hypothetical structures built around entire stars. It sounds like something straight out of science fiction.
It does, but that's what's so fascinating about this whole thing. When you start talking about the limits of information and computation, the line between science fiction and reality gets really blurry. And the video uses the Dyson sphere concept to show just that. Because it's not just about building bigger and better, it's about tackling a fundamental challenge energy.
Great, like you can't power a civilization that spans galaxies with just solar panels and windmills.
Exactly. A Dyson sphere, if we could ever build one, would let us capture all the energy a star puts out. We'd basically have an unlimited power source.
I mean, the idea of harnessing the power of a star is mind-blowing, but how could we even begin to build something like that? Where would we get the materials? It would take a ridiculous amount of stuff, right?
It would be a massive undertaking for sure. But the video points out that the raw materials might be closer than we think. Our own asteroid belt, for example. It's got a huge amount of resources just floating around out there, enough to build multiple Dyson spheres if we are able to mine it all.
Well, I guess it makes sense to start with what's in our own backyard, cosmically speaking. But even if we figured out the materials, wouldn't it take, like, thousands of years to actually build something that massive?
Yeah, it wouldn't be a quick project, that's for sure. The engineering challenges alone would be unlike anything we've ever faced. But remember how we talked about information as a blueprint? Well, the video also touches on this concept of self-replicating machines, and that could speed things up exponentially.
Self-replicating machines, you mean like robots that can build more robots? Isn't that how every sci-fi movie about AI taking over starts?
Well, there are definitely risks to think about with any powerful technology, and the video acknowledges those ethical questions. But imagine, you have robots that can mine asteroids, turn those materials into usable resources, and then use those resources to build these massive structures, all while making more robots to help along the way. Suddenly, a Dyson sphere doesn't sound so out of reach.
I see what you're saying. It's like a chain reaction of building and creation, all powered by information. It's both exhilarating and a bit terrifying.
It really is. And it gets even more mind-bending, believe it or not, because the video goes on to explore the possibility of getting energy from black holes. And that, well, that takes this whole idea of information and energy to a whole other level.
Wait, black holes? Are you serious? Those things are like giant cosmic vacuum cleaners. They suck up everything, even light, right? How do you pull energy out of that?
It seems counterintuitive, I know, but it all comes down to one of the biggest discoveries in physics, Hawking radiation. Stephen Hawking, who unfortunately passed away a few years ago, was brilliant. And he showed that black holes aren't completely black after all. They actually emit a tiny bit of radiation.
Okay, my mind is officially blown. So even black holes, which are like the ultimate keepers of information and matter in the universe, can't help but leak a little bit of energy.
That's the gist of it. It's a tiny amount of energy, but it's there. And theoretically, if you were an advanced enough civilization, you might be able to figure out a way to capture that energy and use it. The video even talks about some pretty wild theoretical concepts, like Penrose processes, which suggest we could actually extract energy from the rotation of a black hole.
Penrose processes, Hawking radiation. I'll be honest, I'm struggling to keep up. But it seems like the possibilities are way bigger than we can even wrap our heads around right now. But let's shift gears for a moment, back down to Earth. Because all this talk about Dyson spheres and black hole energy is fascinating, but it also feels very distant, you know?
Yes.
What about right here, right now? What about the information paradox and how it relates to us, to humanity's place in all of this? The video mentioned something called Life 3.0, which really caught my attention. What was that about?
Ah, yes. Life 3.0. That's a great point to transition to because it gets to the core of what this Homo Deus video is really getting at. We've been talking about information like it's this resource, something to be used and controlled. But what about intelligence itself? Is that just another form of information processing? Is it something we can replicate or even improve upon? Life 3.0 tackles those very questions head on.
Okay, you've definitely got my attention. Tell me more about this Life 3.0. What is it and what makes it so special?
So Max Tegmark, a physicist and AI expert, he came up with this really interesting framework for understanding different stages of life based on their ability to process information and shape their own destiny. He calls the most basic stage Life 1.0, and this encompasses most of life on Earth. It's all about biological evolution. Think of bacteria slowly adapting to their surroundings over millions of years, their hardware, their physical bodies, and their software. Their biological programming are essentially fixed.
Right, survival of the fittest. I remember learning about that in school. But we're not single-celled organisms, so where do humans fit into all of this?
That's where Life 2.0 comes in, and that's us. Humans have this amazing ability to learn and adapt much faster than biological evolution would normally allow. We're not limited by our DNA in the same way. We design our own software, our language, our culture, even our technology.
So we can upgrade our software without waiting around for evolution to catch up. But there's a but coming, isn't there?
You know it. While we've gotten pretty good at designing our software, our hardware is still stuck in Life 1.0 mode. We can't just decide to have wings or gills or to live for hundreds of years. Our biology still has a pretty tight grip on us.
Okay, and this is where Life 3.0 comes in.
Exactly. Life 3.0 represents the next step in evolution, where life can design not only its software, but its hardware as well. Think about a future where we could merge with AI, enhance our bodies with technology, even move beyond the limits of our physical forms altogether.
Whoa, okay, now we're going down a serious rabbit hole. So you're talking about a future where we could potentially escape death, merge with machines, and become these super intelligent, immortal beings. That's sick. That makes sense. Okay, I'm really trying to wrap my head around this idea of Life 3.0. It's like we're taking all these sci-fi concepts and saying, yeah, maybe that could actually happen someday. But you said this idea gets to the heart of what the Homo Deus video is all about. What's the connection there? Is intelligence just another form of information processing, something we can engineer and control?
That's the million-dollar question, isn't it? And the cool thing is, the video doesn't shy away from it at all. It takes us on this journey through all these different levels of information processing, starting with something as basic as a chemical reaction, like burning wood. You're breaking and forming bonds, releasing energy, creating new molecules. There's a kind of basic computation happening there, a transformation of information.
So fire is processing information. I mean, I wouldn't want to try sending an email with a campfire.
Huh. Well, it's definitely more rudimentary than that. But the point is that even at that fundamental level, the universe is manipulating information, transforming it from one form to another. And as systems get more complex, this information processing, it also becomes more complex. Take a biological cell, for example. It's this whole symphony of chemical reactions, and it's all orchestrated by DNA, a molecule that stores and transmits information. It's like a miniature factory, constantly processing information, making copies of itself, adapting to its environment.
I see what you're saying. Life is basically a master class in information processing, even at the cellular level. But when does consciousness come in? How do you go from a bunch of cells sending chemical signals to a being that's aware of itself, that can think and dream and question the nature of the universe?
Now that is the billion-dollar question. And to be honest, we don't have a definitive answer yet. But the video brings up a really interesting idea. What if consciousness, just like intelligence, is an emergent property of systems that are really good at processing information?
Emergent property. So you're saying consciousness isn't something that's explicitly programmed, but rather something that just kind of pops up from the complex interactions of simpler parts.
Exactly. Think about an ant colony. One ant by itself is a pretty simple creature, but together they can do some pretty amazing things, right? They build these elaborate nests, they find food, they protect their colonies, and they do all of this without a leader or a blueprint. It's like their collective intelligence just emerges from all those individual ants interacting.
That's a really interesting comparison. So are you suggesting that our brains are kind of like massive ant colonies with billions of neurons interacting to create this emergent property we call consciousness?
In a way, yes. The video makes the case that the human brain, with its billions of neurons all connected in this incredibly complex web, that it might be the most complex information processing system in the known universe. And it's that complexity that gives rise to consciousness, to our ability to experience the world, to feel emotions, to have thoughts and dreams and hopes for the future.
It's both humbling and awe-inspiring to think about it like that. We are incredibly complex, and yet at the most fundamental level, we are deeply connected to the universe and all its mysteries.
I know, right? And that brings us right back to the information paradox. If we accept that information is physical, that it's part of the fabric of reality, and that complexity and consciousness could be emergent properties of systems that process information in increasingly intricate ways, well, then things get really interesting. The possibilities become pretty much endless.
So where does that leave us? What's the big takeaway from our deep dive into the information paradox?
Well, I think the Homo Deus video leaves us with this profound sense of wonder and a challenge. We're living in a universe where information isn't just something we passively consume. It's a fundamental force, something that shapes the very nature of reality. And as we learn to harness this force, we're not just building tools or technologies, we're pushing the boundaries of what's possible. We're exploring the outer edges of intelligence, consciousness, and even life itself.
It's a lot to process, for sure, but in a really exciting way. It's like we've caught a glimpse of this vast, uncharted territory, and we're the ones who get to explore it. It's both exhilarating and, I'll admit, a little bit daunting.
And that's the amazing thing about it. As we wrestle with these big questions, as we explore the information paradox and everything it makes us think about, we're not just passively observing the universe, we're active participants in its unfolding story.
Well said. And to everyone listening, if this deep dive has sparked your curiosity, if it's left you feeling a sense of wonder and maybe even a little bit of awe, then we've done our job. Keep exploring, keep asking the big questions, and never stop diving deep into the mysteries of the universe. You never know what incredible insights you might uncover.